we're back again. If you had not yet subscribed, please go back to the subscription button, click and then like, and also comment after the lesson. Okay, today we're back with physical science. We're gonna do Doppler effect. We're gonna be speaking about sound waves. We're going to define the Doppler effect according to our exam guidelines, and then go through our formula, and then lastly we're going to do our exam question. Right? Okay. Doppler effect is the change in frequency or pitch of the sound detected by a listener because the sound of the source and the listener have different velocities relative to the medium of the sound propagation. Okay, that is our definition for Doppler effect. Okay, now we'll move to the formula. The formula is FL is equal to V plus minus VL over V plus minus Vs, okay, multiplied by Fs, okay. These signs, you're going to choose them according to the situation you are given, according to the question you are given. We all know that we use plus sign when the source is moving towards the listener. Okay, we use a plus sign because we expect the frequency that is detected by the listener to be higher, meaning that we need a bigger number in the numerator than in the denominator. And obviously, we use a minus sign on the denominator, right? And then we use a negative sign on the numerator only when the source is moving away from the listener, right? Do I understand this? In order for us to get a bigger number from for FL, we need this fraction to be what? To be we need to have a higher value on the numerator and a lower value on the denominator, and we call that an improper fraction. And then when the source is moving away from the listener, we need this fraction to be a proper fraction, meaning that the numerator is going to have a smaller number than that of a denominator. I think that's going to give you a clear understanding of how to use the signs. Okay, let's now go to the exam question. Okay, let's quickly analyze the question and see what is needed. Question 6 is they're given us a statement there. The siren of a stationary ambulance emits a sound waves at constant frequency of 680 hertz. Okay, that is the frequency of the source. It's 680 hertz, right? A man is standing with the detector that records the wavelength of the sound emitted by the siren, as shown in the diagram below. This is the detector, right? And this is the ambulance, this is the man, right? The speed of, now they're giving us the speed of sound in A. Okay, learners, if you're not given the speed of sound in A, you can quickly check your data sheet. For sure, you're going to be given 343 or 340 on your data sheet. And also, you can just keep it in mind that the speed of sound in air is 343. But in this case, they're giving us as 340. Now we have our velocity of the sound as 340 meters per second, right? Another thing that we know is that is the velocity of the observer, because what they say, okay, another thing that we give in here in this case is the velocity of the source, meaning that the source Vs is 0 because they're saying the ambulance is stationary, right? Okay, let's try and tackle the first question. 6.1, they're saying calculate the wavelength of the detected sound. We have the velocity of the sound in air and we have the frequency. Now they want lambda. We know the formula as V equals F lambda, right? We have our velocity of the sound as 340 and we are given the frequency of the source as 680 hertz. Now we're looking for lambda, which is the wavelength. Now we're going to quickly substitute or make lambda as the subject of the formula. Okay, now we can substitute. The velocity is 340. Now the frequency is 680. Never mind about the units, you're going to put it after you got your answer. Now you can quickly punch 340 over 680. That's going to give us 0.5 meters. Now we have our wavelength as 0.5 meters. Now, okay, now we've already bagged our 3 marks. Now we're moving to the next question. They've also given us a new statement that states the ambulance now moves at constant speed along the road towards the man. The detector now records the wavelength of the sound, which differs from the previous reading by 0.05 meters. Okay, now this is a different question, and this was 6.1. Now this is 6.2. Now they're saying state Doppler effect. Now, as we have stated Doppler effect, we know that Doppler effect is the change in frequency of the sound detected by a listener, because the sound of the source and the listener have different velocities relative to the medium of the sound propagation. That's how you get your 2 marks, by just stating the Doppler effect according to exam guidelines, so that you can get all the full marks. Okay, now let's quickly move to 6.3. 6.3, I'm not gonna put down the Doppler effect because I've shown you guys the first slide. Okay, 6.3, how would each of the following have changed when the ambulance approached the detector compared to when the ambulance was stationary? Now they're asking, okay, let me bring it closer so that we can all see. They're asking how would each of the following have changed when the ambulance approached the detector compared to when the ambulance was stationary. Okay, learners, we know that when the source approaches the detector or the listener or the observer, what happens to the frequency that is observed by the detector? It increases, right? But when the source is stationary and the observer is stationary, they get what? They observe the same frequency. They get the same frequency. The observer gets the same frequency as the source. But when the source is moving towards the observer, that means that the frequency detected by the observer increases. But when the ambulance is moving away from the observer, the frequency detected by the observer decreases, right? I hope you all noted that. Now, in this case, they want to see, they're asking us how is the frequency going to change when the source is approaching the observer. 6.3.1. Now we're going to put down our answer. Now they're asking the distance. Okay, choose from increased, decreased, or no change. They're asking the distance between the wave fronts. When the frequency increases, what happens to the wavelength? It decreases, right? The wavelength decreases. So the distance between the wave fronts, it decreases. So the answer for question 6.3.1 is decrease. Right, now let's move to 6.3.2. Now they're asking the frequency of the detected waves. It increases. When the wavelength decreases, the frequency automatically increases. So it is increased. And now we got our 2 marks there. Now we're going to move to 6.4. They're saying calculate the speed of the ambulance. Okay, let's analyze this properly. All right. We know our formula is FL equals V plus minus VL over V plus minus Vs multiplied by the frequency of the source. Okay. At first, they told us, okay, let's quickly go back and read the statement, the second statement. It says the ambulance now moves at constant speed towards, let's note that towards the man. The detector now records the wavelength of the sound which differ from the previous reading by 0.05 meters. So we did calculate the wavelength and we got 0.5 when the source was stationary. Now they're saying the new wavelength is different by 0.05. So from 0.5 minus 0.05, our answer is 0.45 meters. That's our new wavelength, right? From the new wavelength, we can easily calculate the frequency that is heard by the observer, which is our FL. You can do it aside or simply put it in the formula. We're going to quickly calculate the frequency of the listener, FL. We're going to use that formula, V is equal to F multiplied by lambda. In this case, we've made the frequency subject of the formula already. So we have our velocity as 340 over our lambda in this case is 0.45. We can easily get our frequency as 755.56 hertz. I hope we all got the same answer. Hertz. Okay. Now we're gonna go to our original formula to substitute. 755.56 equals our velocity of the sound. In this case, it's approaching, the source is approaching the observer, meaning that it's going to be a plus sign. And then we have the velocity of the observer as 0 because it's stationary, over the velocity of the sound is 340. We said we're going to have minus, so the velocity of the source is what we are looking for. And then the frequency of the source remained as 680. I don't think I have enough space there, but we can all see. Now you can, from this point, it's just mathematics. So we're gonna we're gonna try to avoid big numbers. We're gonna try and divide both sides by 680. We're gonna have 1.11 equals 340 divided by 340 minus Vs. Now we're gonna try and cross multiply and make Vs as the subject of the formula. 1.11 multiplied by 340. We're gonna get our answer as 373 or 77.78. Okay, let's say 377.78 minus Vs. Vs which is also multiplied by 1.11 equals 340. This looks very clumsy, but we're gonna make where do I write Vs, subject of the formula. Now we're gonna move that 377 or we're gonna move Vs to the other side to become positive and divide by that 1.11, right? So 340, 377.78 minus 340, we get 37.78 divided by 1.11. Our answer is 34 meters. I don't have space. Meters per second. That, guys, is our final answer. That's the speed of the ambulance towards the observer. I hope we all understood, and if you have any questions, you can just comment down below, or yes, you can comment down below, and then I will come back and explain further to you privately. Okay, thank you so much. Enjoy the rest of your day, and please don't forget to subscribe and also share the lesson for the others to get help. See you next time.